So next is rational inequalities. So again, what is rational inequality? Rational inequality is an inequality that involves rational expressions. So the following competencies for this lesson: find the critical points or critical values, solve rational inequalities, write the solution set in set builder and interval notation. So we have steps in solving rational inequality. So the steps are the following. Number one, we make one side of the inequality equal to 0. How do we make one side of the inequality equal to 0? We have to get the common denominator or the LCD and then combine similar terms. After we set the inequality to 0, we are now ready to find the critical values for the numerator and the denominator. I'll discuss in detail how to look for the critical values later. Next, after finding the critical values, you have to graph the solutions on the number line and then test each interval on the number line to find the solution set. So for example, you have the given inequality 2v all over v minus 3 less than 0. So if the given inequality is one side of the given inequality 0 already, yes, it's 0 already. So we move to finding the critical values both for the numerator and the denominator. To find the critical values, all you have to do is to equate your numerator and denominator to 0. So that is 2v equals 0. Then solve for v. You have v equals 0. And then for the denominator, v minus 3 equals 0. V is equal to 3. So plot it in your number line. So you have 0 and then 3. So please take note that we use an open circle for 0 because the inequality symbol used is less than. So recall, if it is less than or greater than, we use the open circle or open parenthesis. If it is less than or equal to or greater than or equal to, we use a shaded circle, meaning that point is part of the solution set. In higher mathematics, bracket is being used. So please take note of that one. Okay. So 0 open to circle and then 3 also open circle. If it is critical points in the denominator, it's always an open circle regardless of the symbol. Why is that? What do we mean by that one? Since since it is in the denominator, that particular value will make the expression undefined. That's why it's an open circle. So after plotting the critical points in your number line, observe it's divided into 3 sections. So now we are after to looking which part of the number line is part of the solution set. So in this particular case, how do we look for the parts of the number line or the interval that is part of the solution set? So all you have to do is to test a point, any point to the left of your critical points. So in each interval of on your number line. So in this particular example, we have here -1. So to the left of 0, -1. Between 0 and 3, 1. And then 3 to positive infinity, 4. So your test value, all you have to do is to substitute the test value in your inequality. So 2 times -1 over -1 minus 3. So that is positive 1/2. Is positive 1/2 less than 0? Is it a true inequality? So it's not a true inequality, so it's not part of the solution set. Again, all you have to do is to substitute any value in the interval to the given rational inequality. So this time, in this particular interval between 0 and 3, we have 1. So substituting 2 times 1 over 1 minus 3, that's 2 over -2. So it's -1. Is -1 less than 0? Yes. Next, 4. 2 times 4 is 8. 8 over 4 minus 3, that is 1. Is 8 less than 0? So false. So what do we mean by that one? In the after substitution of the given value, when do we have a true statement? That means that is the solution set of the inequality. So in this particular case, between 0 and 3. So to write that one in interval notation, so meaning from what point to what point. So since it's not part of the solution set, we use parentheses. So 0, comma, 3. So again, this is in interval notation. So for set builder notation, the solution set is V such that V is in between 0 and 3. So this is the interval notation, and this is the set builder notation. So that's for the first example. So let's move on to the second example. So this time, it's n minus 2 over n plus 4 greater than 3. So the first step is to make one side equal to 0. So since 3 is on the right side, we transpose it to the left side. So meaning we subtract 3 both sides. And then we simplify this inequality by looking at our least common denominator and then simplifying the inequality. So here the LCD is n plus 4. Simplifying, you have the simplest inequality. Okay. So next step after we have the simplest inequality is to look for our critical points or critical values. So you have numerator -2n minus 14 equals 0 and equals -7. Denominator n plus 4 equals 0 and equals -4. So plotting it in the number line, you have -7 and -4. Then again, you look for test points in each interval. So it's divided into 3 intervals. Any test points will do. So here we have -8. Substituting -8, here -8 is substituted in the original rational inequality. But you can substitute it in the simplest inequality. So what is the sign that is greater than 0? So we need a positive value. Let's try to substitute the given values in the simplest inequality. Here, it's indicated if you substitute it to the given inequality, the one that will give you a true statement is the second interval. Let's substitute the same inequality. So we have -8. So that means -2 times -8 minus 14 all over -8 plus 4. So simplifying, this is positive 16 minus 14. So you have 2 over -4. Is it greater than 0? So obviously, this is false because it's negative. Next, so between -7 and -4. So we have -5. So -2 times -5 minus 14 all over -5 plus 4. So this is positive 10 minus 14. So that's -4 over -1. Negative over a negative. So this is positive. This is equal to positive 4. Is it greater than 0? Yes, it is greater than 0. Again, you can substitute it to the given inequality or in the simplest inequality. So let's have the last value. So for example, we have 0. So this is -2 times 0 minus 14. Is it 0 plus 4? So this is negative 14 over positive 4, which is -7 over 2. So it's not greater than 0. So this is false. So again, the only solution is this region. So that is the value of n is greater than -7 but less than -4. So in an interval notation, it's an open parenthesis, -7, -4, set builder, and such that n is in between -7 and -4. Next example. So this time, we have the inequality 4t plus 5 all over t greater than 3. Again, make one side equal to 0. So we transpose 3 again to the other side. So we have -3 to the other side. So we subtract both sides by -3 and then we simplify. So simplifying, you have t plus 5 all over t less greater than 0. So we have the simplest inequality, get the critical value. So you have -5 and 0. Plot it in the number line, -5 and 0. Then substitute. Now, again, test each interval to determine what is the solution set for the given inequality. So again, let's just substitute in the simplest inequality. So we have -6. So -6. So what is the sign that is greater than 0? So we need a positive. So -6. So that's -6 plus 5 over -6. Is it greater than 0? So this is -1 over -6. Is it greater than 0? So this is positive 1/6 greater than 0. So it is true. Next, in between -5 and 0, so we have -1. So we have -1 plus 5 over -1. Is it greater than 0? So this is +4 over -1. So obviously, it's -4. It's -4 greater than 0. So this is false. Now, let's substitute 1. So we have 1 plus 5 over 1. So this is 6. Is it greater than 0? Yes, so this is true. So that's why the shaded region is this part and this part. So here we use the symbol or union. So from where to where? So it's -infinity to -5, from left to right. Union, the other solution set, 0 to +infinity. So that is our interval notation. For set builder, all you have to do is to rewrite it in the way it is t such that t is less than -5. So this is the values are less than -5 to the left of -5 and to the right of 0. That's why it's greater than. Next example. So the steps are the same. So this time, the example given is 3a minus 5 all over a plus 1 less than or equal to 2. So again, make one side equal to 0. So we have transpose +2. So that's why you subtracted -2. Then simplify. How do we simplify the inequality? We do not multiply both sides of the inequality by the LCD. We only simplify one side of the equation. Why is that? Because you don't know whether the one that you are multiplying is a positive or a negative. So simplifying the inequality, so you multiply LCD is a plus 1. So the resulting inequality, so recall how to perform operations on rational expression. So we have a minus 7 all over a plus 1 less than or equal to 0. Once you have the simplest inequality, equate the numerator to 0 as well as the denominator to find the critical values. So plot the critical values. So we have -1. It's an open circle because it's in the denominator. And then 7 is a shaded circle. Now, test a point in each interval. So to make it easier, substitute in the simplest inequality. So we have, so what is the sign that is less than or equal to 0? So we need negative value. So instead, let's substitute. So -2 minus 7 over -2 plus 1. Is it less than or equal to 0? So this is -9 over -1. Is it less than or equal to 0? So you have positive. So it's false. Second test point. So we have 0. Again, any test point will do as long as it's in the given interval. So 0, obviously, that is -7. Is -7 less than 0? Yes, it's less than 0. Next test point is 8. 8 minus 7, 1 over, so it's positive. So that's why the solution set is from -1 to 7. But -1 is not included. That's why we use parentheses. 7 is included. We use bracket. So this is the interval notation. Set builder notation, A such that A is greater than -1, greater to the right, but less than 7, to the left of 7. So please take note when to use an open parenthesis and a bracket. Next example. So we have 3x plus 7 over x plus 3 greater than 2. So again, make one side equal to 0. So transpose to the other side. So you have minus 2 both sides. Then simplify, finding the LCD. So you have x plus 3. Then, so this is negative 2x. So minus 2x minus 6. That's why it's 1 over x plus 3. Then get the critical values. So you have negative 1 and negative 3 plotted in your number line. Then get a test point in each. So negative 4, negative 2, and then 0. Then substitute. So here we have greater than. So what is the sign that is greater than? Positive. So substituting, let's have negative 4. So substituting it orally, negative 4 plus 1 is negative 3 over negative 4 plus 3, negative 1. So it's positive. So meaning true. So for this part, it's true. Negative 2 plus 1 is negative 1 over negative 2 plus 3, which is positive 1. So we have negative. So this is false. So here again, the sign of the answer is positive. Here it's negative. So 0, so it's positive. So that's positive 1/3. Okay, so I'm not writing the solution anymore. It's not required to write the solution in substituting, but it's if you are not at ease in solving mentally, you can write your solution, or you can not solve it mentally, but you have to write the solution. So here we need a true statement. So that falls from the interval that's part of the solution set is this side and this side. So what do we mean by that one? Values that are to the left of negative 3, so less than negative 3, and to the right of negative 1, so greater than negative 1. That's why you have the interval notation from negative infinity to negative 3, union, or from negative 1 to positive infinity. In set builder notation, it's x such that x is greater than, or rather less than negative 3 or greater than negative 1. Next example. So we have here x minus 2 over x squared minus 16 less than or equal to 0. So in this case, it's already, one side is already 0. It's already equated to 0. So we can get the critical values. So critical values of the numerator, x minus 2 equals 0. So x equals 2. And then denominator, in this case, is a binomial. So we have x squared minus 16. So we have critical points 4 and negative 4. So plot all the critical points on the number line. So it's less than or equal. The critical points of the numerator is closed circle, denominator, open circle. So this time, the number line is divided into 1, 2, 3, 4 intervals. So you have to check which of the intervals are solution set again by substituting it in the given inequality. So as you can see, if we will substitute, so from left to right, -5, it's true. For in between -4 and 2, the value substituted is 0. It's false. And then between 2 and 4, the value substituted is 3. So it's true. And then 5, it's false. So we have a true statement here and here. That's why that is the solution set. So that is the numbers to the left of -4. So negative infinity, -4, yun. Since 2 is included, we use bracket 2, 4 not included. So in set builder notation, again, interval notation, set builder notation, x such that x is less than -4, or disregard the symbol, or x is greater than or equal to -2 but less than 4. Again, disregard the symbol. Okay, next. So same. The only difference of this one from the previous example is the given in your numerator is also a binomial. So let's find the critical values because this is already 0. Numerator, you have 2, 2 and -2. Since it's less than or equal to, closed or shaded. Denominator, -4 and 4, always open. No. Now, what part? How many intervals? So you have 1, 1, 2, 3, 1, 2, 3, 4, 5 intervals. So you have to identify which of the intervals are solution set. How do we do that? You test a point at each interval. Again, any point will do. So testing a point, substituting in the given rational inequality, it's false for the first interval, negative infinity to -4. In between -4 and -2, it's true. False in between -2 and 2. True in between 2 and 4. And then false bit 4 to positive infinity. Again, how do we do that? We substitute the value to our inequality, then identify if the resulting inequality is true or false. Meaning, is it less than or equal to 0? So here, less than, we need a negative value. So in this particular case, the negative value that we have is this one and this one. So that's why the solution set is this region as well as this region. So it's in between -4 and -2 as well as 2 and 4. -4 is not included. -2 is included. Here, 2 is included. +4 is not included. So it's not included, parenthesis, -4 to -2, union, 2 is included, up to 4, not included, parenthesis. So this is interval notation, set builder notation. So you have x such that x is greater than -4 but less than -2, or x is greater or equal to -2 but less than 4. So down to the last two examples. So again, First step in solving the inequality, make one side equal to 0. So in this particular case, the given is g minus 11 over g plus 5 minus 2 less than 7. So obviously, one side of the equation is not equal to 0, so we have to make it equal to 0. How do we do that? Transpose 7 to the other side. So minus 7, that's why it becomes negative 9. Then simplify one side of the inequality by finding the LCD. So you have 8g minus 56 over g plus 5 less than 0. Equate the numerator. So you have negative 7, denominator negative 5. So 3 intervals. Get the test point and substitute. I suggest you substitute it in the simplest inequality. So either of the two, but it's easier if one side is already 0. So here, substituting with the three values. So it's true. So here we need less than 0, a negative sign if we will substitute here. So it's true in this region in which we substitute negative 8 and also in this region. I'm not showing the substitution of each value to the given inequality because all you have to do is to identify if you'll arrive with a true or false inequality. If it is a true inequality, it's part of the solution set. If it's false, it's not part of the solution set. So here the solution set is to the left of negative 7, so negative infinity to negative 7, union 2, the right of negative 5 to positive infinity. In set builder rotation, G such that G is less than negative 7 or G such that G is greater than negative 5. Interval set builder. Last example. So this time is 3d plus 2 over d plus 4 greater or equal to 1. So first step, make the inequality, make one side of the inequality 0. So transpose 1. So that's it's negative 1. So simplify. You have the LCD is d plus 4. So you have 2d minus 2 over d plus 4. This is the simplest inequality. So equate the numerator and the denominator to 0 to find the critical values. So D1 is for the numerator. Since the symbol is greater or equal, so it's a shaded circle, meaning that is part of the solution set. Here, negative 4, even if the symbol is greater than or equal, since it's in the denominator, it's open circle. Okay, so you have now the test point. Substitute to the simplest inequality. I'll substitute in the simplest inequality. So negative 5. So negative 5. So 2 times negative 5 minus 2 all over negative 5 plus 4. Is it greater or equal to 0? So this is negative 10 minus 2, negative 12 over negative 1. Is it greater or equal to 0? So this is true. Second test point, 0. So if you substitute 0, that it will resolve 2. So 2 times 0 minus 2 all over 0 plus 4. Greater or equal to 0? Obviously, it's negative 1/2. So it's not greater or equal to 0 because it's negative. Last value, 2. So you have 2 times 2 minus 2 over 2 plus 4. Is it greater or equal to 0? So this is 2 over 6, 1/3. So it's positive. It's true. So same if we substitute in the given inequality. So that is why this is the region that is part of the solution set. So to the left of -4, negative infinity to -4, union 1 to positive infinity. So in set builder notation, D such that D is less than -4 or D is greater than or equal to 1. So that's it for rational inequalities. So again, to solve for rational inequalities, first step, make one side of the inequality equal to 0. Second step, find the critical points or critical values. Plot it on the number line. After looking for the critical points or critical values, plot it on the number line. And then to look for the solution set, what interval is the solution set of the given inequality? Test a point. After testing a point, identify the interval that is part of the solution set.